Mirrors. We interact with them on a daily basis. But what are they, and how do they really work? Essentially, a mirror is any extremely smooth surface that can't absorb photons. So instead, when a ray of light hits it, since the photons can neither be absorbed by or go through the object, they bounce off and the light reflects, hitting your eyes, which is why you can see a mirror image. But all mirrors work on this basic principle. But when you add a curve to the mirror, it creates some pretty interesting effects. And that's what we'll be focusing on in this video.
What we've taken here is we've taken a mirror that's curved inwards. And so what we're doing is this pendulum here, we're going to swing it back and forth. And what do you think you're going to see in the mirror?
The eraser.
Yes, but what will happen to the eraser?
It's going to be swinging back and forth.
Okay, but what will the image look like in the mirror?
Way it is right now.
Yeah.
It'll just stay the same?
Mm-hmm. Stay the same.
Even though the mirror's curved, you don't think that will affect it at all?
Nope.
Okay. So I guess you can kneel down now. So do you still see it now?
I see it now, yeah. I see it now.
See what you say?
That's cool. Wow, that's very amazing. Never thought it would happen. So cool.
Wow.
Okay, so what did you see happen?
Well, what I saw was the eraser going forward, and when it came back, it goes backwards and upside down. When I saw it in the mirror.
Why do you think that happens?
Because it's curved.
Why does the curve, how do you think that affects it?
Science.
So here we have a concave mirror, which means it curves in ever so slightly.
That's true.
So eventually, soon, I'm gonna pull back on this pendulum and let it go. And I want you to tell me what you think is gonna happen to the mirror, like the image in the mirror, and why you think that's gonna happen.
Okay. Right now?
Yeah, go ahead. Give your guess.
Since it's concave and it's a mirror, when you push it forward, it's probably just going to enlarge it, and when it goes back, just get smaller.
Yeah?
I guess.
Okay, so if you right where I was, you might need to crouch down a little bit. So can you see the?
Yeah, because the engine would have to be on this thing. And that's why.
Whoa, that's so trippy.
So now that you've seen the effect, what do you think is causing that?
Well, when it's, closer to the mirror, I'm going to assume the light is reflected closer, and when it's farther away, light's reflected farther away at the point at the bottom compared to the top.
Setup, right? We have the concave mirror, we have a pendulum swinging back and forth in front of it. So what do you think the image is going to look like on the mirror?
It's gonna be bigger.
It's going to be what?
It's gonna go like when it goes towards the mirror, it's gonna be tiny. Yeah, when it comes to me, it's gonna be huge.
So when it comes towards you, it's bigger,
Yeah.
and closer to the mirror, it's smaller.
Yeah.
Okay, let's find out. So if you crouch down right next to it, try the straight. Do you see it here?
Oh yeah, I already got that.
Okay, I did get it.
It's still looking like a circle.
No, I see it. It's like coming at me and then like going past it and like I can't see it.
Like the
and then
image is flipping, right?
Yeah.
Did you see the flip?
Kind of. Yeah.
Okay. So basically, why that happens, or why do you think that happens?
Well, we could conceivably
'Cause
crash it and
goes
damage the
out
motor.
of it goes into my blind spot. in my-
So I mean, it
between
could
my
snap the
nose, so then I
fuselage
don't
again,
notice
it
and
could
then when
snap
comes
the
back,
wing. I mean, other
looks
things
bigger.
can go wrong. Toss the rocket
What
would
do you know
burn
about
off
mirrors?
half of your stabilizer.
Ghost Rider.
Conclave and convex.
That's our name, you can't take it.
Ghost Rider.
Okay.
And then
Oh, you mean like
one
the comic character?
conclave
That's
or
on
concave.
fire?
Yeah.
Yeah, I don't know how far we get
Goes
before
in.
we lost
Yeah, it
the
goes in, yeah.
stabilizer.
And then convex
And
goes outward.
based on the fact that we have a concave mirror here, what do you think is going to happen?
I'm trying to get some
When this
data
swings
on
towards
it.
it?
When we pull it up and let it swing back and forth, what do you think is going to happen to the image in the mirror?
Here's the whole product.
I think when this swings closer, not only is it going to get larger, but the actual like shape of the eraser is going to distort.
Okay, and if it swings further away?
Probably gets smaller,
Okay.
less
okay.
distortion.
So if you're going to kind of have to kneel down and close one eye until we make sure it works properly. So if you make sure you can see it as you pull it away. And then when you let go, if it's relatively straight, hopefully the effect will work properly. So, you see anything interesting happening?
Kind of distorting, or like.
Okay. I'm gonna
You swing it.
Because it might
try
tell
to
us
swing
if it's
this
not
as
in a fan, what side
straight
you
as possible.
Sometimes it's hard to estimate. The other way to do it is trial and error with the current meter and see what, start out small and see what fits it.
As it slows down, I think it'll be easier to see what's happening.
Look up color.
It gets significantly larger.
Now that you've seen the effect,
Basically
why
what's
do you
on the
think
box
that
for
happens?
it.
What do you
So
think
it's
causes
the
that?
small black ones, the 19 KV ones. So it's just
Is
that
it-
provided a
It's
lot
when
of noise,
when
so
this gets
it's a little
farther,
bit more dangerous
it
to
goes
throw
reverses,
there, 'cause you
right?
have to watch where the propellers are gonna hit
Well,
you.
probably because the way we see, so like the light's going in there, and then the way the light bounces
This is from the spring, and that's from
back.
This is actually just from burning myself.
I don't know how to explain this.
Yeah, that was a burn.
I know that when you're like the way you see, when light, the things that enter the top of your eye are actually coming from below, so everything's reversed.
Yeah.
So like probably kind of similar with this, where
Yeah.
the way the light enters the mirror is
Maybe.
Okay, here we go. So it was a
different from when it would be like.
When you look at the concave mirror, it works as you've seen very differently than the regular mirror. Let's draw a diagram to illustrate. As light particles bounce off the mirror, instead of bouncing off at the same angle they hit, they always bounce off at a predetermined angle. No matter where the light hits, based on the curve of the mirror, it always comes to this point. That point is called the focal point. But the light doesn't stop there. As you know, light is continuous, it keeps going. So what we have here with the pendulum, when the pendulum is closer to the mirror, we can see that the light is in standard orientation. The top is on the top, the bottom is on the bottom. But when the pendulum passes this focal point, the light's flipped. As you can see, the light from the bottom is now on the top, and the light from the top is now on the bottom, which is why the image flips. Also, at the focal point, it's blurred. So, because the light is crossing, that's where it's intersecting. So that's why it appears to be out of focus at that point. And this is how our effect works.
Wow.
Power physics.